Hello everybody, Mr. Keeney here. Continuing our Algebra Geometry 2 notes, we're going to continue looking at deductive reasoning and using it to form logical arguments. Today we're going to be continuing our 2.6 notes. This is our day 3 notes of it, and we're going to be writing proofs using geometric theorems, postulates, properties of equality, and this is a new one, properties of congruence. So less of writing the actual proofs and more giving us tools when we do write our proofs. And you'll see what I mean as we go on. But you're going to see in these notes less of proof writing and more of here's some more tools we have to work with. So the first thing it says, a blank is a statement that can be proven. So a theorem, I was thinking, do I try to make them think about it? No, I'll tell them. A theorem is a statement that can be proven. So we are going to be talking about a theorem that talks about congruence. And it's going to be working with these similar ideas of reflexive, symmetric, and transitive. So a good review, and also it's going to be talking about congruence. Congruence, not equality. So reflexive property in the past was saying that something equals itself. So segment AB would be equal to AB. With the congruence of segments here, we would say that segment AB is congruent to itself, segment AB. So it still does the same property, but just with congruence instead of equality. Symmetric switches, remember we think reflexive repeats, symmetric switches. So if it says segment AB is congruent to segment CD, then, and I'm going to switch the order, segment CD is congruent to segment AB. We know for the symmetric property, that's the symmetric property of congruence instead of equality. And then finally here, the transitive property says that if AB is congruent to CD, and then CD, we see that these two here, they are the same segment, is congruent to EF, well, we can make a conclusion that segment AB is congruent to segment EF. So transitive property, also one that we have had in the past, and it works for congruence just like it does equality. And not only does this work for segments, so you're going to see down here we have the congruence of angles. So we're going to have the same kind of theorems here. We have reflexive, symmetric, transitive properties. I shouldn't say theorems. So for any angle A, what I know is that angle A is congruent to angle A. Notice I'm not putting the measure of angle A because measurement deals with equality. We are working with congruence, so it is congruent to itself. Symmetric, if angle A is congruent to angle B, then I can switch that and say, well, angle B is congruent to angle A. And the transitive property should be similar right now. We'll see that A is congruent to B, B is congruent to C, so I conclude that angle A is congruent to angle C. So we have these kind of new tools. Really the big thing that is new here, and again I kind of pointed it out, and maybe I'll have it for your notes here, is congruence instead of equality. Now we're going to run through examples. The first one we're going to be completing the statement, and the second one we're going to be saying which property is being used. So for the first one, use the property to complete each statement. So the first one says reflexive property of congruence. So reflexive means repeat. Oh, I almost missed it there. So if blank is congruent to SC, the reflexive property says something is congruent or equal to itself. So we will put SC is congruent to SC. Symmetric switches. So symmetric property congruence, if blank is congruent to blank, then angle RST is congruent to JKL. Well, I'm just going to switch those. So angle JKL, that's going to come first, congruent to angle RST. Symmetric switches. And then transitive, if F is congruent to J and blank is congruent to blank, then I know that F is congruent to L. Well, angle J is going to be the one that kind of connects the pieces here. And then if I want F is congruent to L, then angle J is congruent to angle L. And then our final kind of example, I think it's our final example, yes it is. Name the property that goes with the statement. If DG is congruent to CT, then they switched it, and CT is congruent to DG. Switching is symmetric. And here's the new thing we'll have to do. PO, instead of E for equality, we're going to put C because of these congruency signs. Next one says VWX is congruent to itself, so reflexive. Reflexive says something is congruent to itself, reflexive. And this one's also going to be POC because the C is that congruency symbol. And I'm going to highlight that one because this one's reflexive as well, but it's POE, because of the equal sign. And then our last one here, JK is congruent to MN, MN is congruent to XY, so I can say JK is congruent to XY, so this one is a transitive property. And this one is property of congruence. And I will go ahead and highlight it because we only got one more. That is our reason why. So that is the notes. These are just a couple more little tools, not too much new, but just something for extra practice, extra tools in our toolbox when we are completing those proofs. So thank you for watching. Let me know if you guys have any questions, and I will talk to you later.